Hello students, welcome to e-learning. Today we are going to solve basic problem in shear force and bending moment taking cantilever beam. So first we have one question given here. A cantilever beam of length 3 meter subjected to a point load of 5 kilonewton, 8 kilonewton and 12 kilonewton at a distance of 1 meter, 1.5 meter and 2.5 meter from the free end. Okay, so respectively, so 5 kilonewton is acting at 1 meter from free end, 8 kilonewton load is acting at 1.5 meter apart from free end, and 12 kilonewton is acting at 2.5 meter from free end. Draw shear force diagram and bending moment diagram. So this is how the drawing should be. Line diagram. In the examination, first and foremost thing, you have to draw such line diagram for the question given. So you can see 5 kilonewton is acting at 1 meter, 8 kilonewton is acting at 1.5 meters from free end, right? 12 kilonewton is acting at 2.5 meters and the total span given is 3 meters, right? The cantilever beam of length 3 meters span. Now next we will continue with solving the shear forces. The figure is given here. Shear force calculation. First and foremost thing, we will start from the free end, means we will start from right end and proceed towards left end. Okay, that is point A. So first and foremost thing, shear force at B, ahead of B, for beyond B there is no load, so directly you can write 0 kilonewton, there is no force, right? Next, shear force at C, there is no force beyond C, it means shear force at C left, or sorry, shear force at C right, okay, it will be 0, so that is nothing but 0 here. Then shear force at C left, when you stand left of that point load 5 kilonewton, okay, you will come across one load acting at C point, right? That is 5 kilonewton. So shear force at C will be 5 kilonewton. Next, shear force at D will be shear force at D right. Consider D right. It will be only 5 kilonewton, right? See, shear force at, when you stand on the right side of D, there is only one load acting forward beyond point D, right? That is 5 kilonewton. So this is shear force at D right. When you stand on left side of D, okay, so you will come across 2 point loads acting from the point of D left, when you stand at the left side of the D. So that is the addition of 5 kilonewton and 8 kilonewton here. Okay, so next, shear force at E. Now shear force at E right, okay, you have these two loads acting, correct, and that is 8 plus 5 is equal to 13, right? 8 plus 5 is 13. Now this 12 is nothing but when you stand shear force at left of E, okay, so shear force at right of E is only these two loads, and when you stand shear force, when you write shear force at E left, okay, you will add this load also, that is 12 kilonewton. Okay, now coming to shear force at A. Shear force at A beyond, we are taking all the loads which are on the right side of that particular point, correct? So shear force at A will be all the addition of sum of all loads acting forward from A. Okay, so that is 12 kilonewton, right? That is 12 kilonewton, 8 kilonewton and 5 kilonewton. So totally it will be 25 kilonewton. So these are the values for shear forces, okay, acting at respective points, that is A, E, D, C and B. Now coming to calculation of bending moment. Bending moment calculation, first and foremost thing, all loads, A point is fixed and all loads are going to act downwards. So these downward forces are right side of or it is going to rotate the beam in clockwise direction. Okay, so shear bending moment at point B, there is no further load acting, so directly the 0 kilonewton meter, so there is at free end of the cantilever bending moment will be always 0. So now next is shear force at bending moment at C point. Moment at C, beyond C there is no load. C to B span in 1 meter there is no load, that is why again no bending moment is going to have its effect. Now coming to bending moment at D. Bending moment at D, 5 kilonewton is acting downwards, so we have taken sign clockwise moments, we have taken negative, so minus 5 into 0.5, because we are taking moment at point D. So this 5 kilonewton is going to have its perpendicular distance till D as 0.5, because 1.5 minus 1, the remaining one is 0.5 meters, correct? So force into perpendicular distance, minus 5 is force and 0.5 is perpendicular distance, force into perpendicular distance. So it is going to have minus 2.5 kilonewton meter as moment, bending moment. Now slowly come to point E. Now we have loads acting from E are 8 kilonewton and 5 kilonewton. Two loads are acting further E point. So we are going to take the calculation in consideration. So here minus 5, all loads are acting downwards, so all moments will be negative, all the moments will be in clockwise, so clockwise moments are negative. So 5 into this distance, that is 2.5 minus 1, it will be 1.5 meters. So here it is. So next is minus 5 into 1.5, we have finished. Coming to next load, that is minus 8 into this distance, because we are taking moment at E point, see here at E. So we are going to have minus 8 into this distance, that is perpendicular distance, force into perpendicular distance, so it is going to rotate in clockwise direction, so minus 8 into 1. So how 1 meter, this is 2.5 totally, correct? In this 2.5 minus 1.5, you will remain with this distance, that is 1 meter, correct? Coming to next, so there is no load in this span between D and E, so we are going to not consider anything. Now 12 kilonewton is acting at the same point, correct, where we are taking moment. So force into perpendicular distance is 0 here at the same point, so anything into 0 is 0, so 12 into 0 is 0, so that moment is not considered. Okay, so this is the calculation, and moment at E is minus 15.5 kilonewton meter. Now moment at A point is phi. Moment at A will be phi into this distance, that is 3 meter, minus 1 meter, that is 2 meter. Okay, minus phi into 2, then minus 8 into 1.5, because exactly it is acting in the center, 3 meter and 1.5 meters. Coming to next, minus 12 into this perpendicular distance, so that distance is minus 12 into 3 meter minus 2.5 meters, right? So it will be 0.5 meters, so minus 12 into 0.5, so moments will be minus 5 into 2, minus 8 into 1.5, minus 12 into 0.5. These are the calculations. You will get the answer as minus 25. You will get the answer as minus 25 point. Sorry, the answer is minus 28 kilonewton meter. Okay, so now how to draw these? We have got all the values, that is shear force at all the points, moments at all points. Here moment at A is not calculated, in the sense it is not typed, but the explanation has been done how to take moment at A. So taking that, we have got this answer as minus 28, right? So first and foremost thing, below this line diagram you need to project all the lines at all the point loads and UDL loading, okay, below, like this. Then you have to mark horizontal baseline, reference line for shear force diagram as well as bending moment diagram. So all the shear force values are positive and all the bending moment values are negative. So that is why here we have taken reference line for bending moment, and below we have taken minus values, negative values, and here we have taken reference line for shear force, above reference line all positive values, and below reference line all negative values. Here also same thing, bending moment reference line, above positive values, below negative values. Next, mark moment at shear force at B as 0 kilonewton, that is this value. Shear force at C left, that is 0 at the base. Shear force at C we have 5 kilonewton. Shear force at D we have 13 kilonewton. Mark on that, on the same line you have to mark 13 kilonewton. On E line we have to mark 25 kilonewton. Okay, then we have to mark 25 kilonewton at A point, but see that you have to take shear force at C right, shear force at C left, shear force at D right, shear force at C D left, shear force at shear force at E right, shear force at E left values, so that you can mark these values 5 kilonewton, 13 kilonewton. Okay, so similarly join all the points like this, and then shear force diagram is ready. Now coming to bending moment diagram, shear force at B is 0, shear force at C is 0 again, shear force at D is minus 2.5. On this D line my mark 2.5 kilonewton meter. Shear force at E mark minus 15.5 kilonewton meter, and shear force at A we have got minus 28. Mark that point and then join all these and finish the bending moment diagram. So this is negative bending moment diagram. So it is showing us how and how much moment at what span we are going to have in that particular beam. Okay, so between A to E there is maximum bending moment, between E to D there is a little bit lesser moments, and D to C we have less moments, and between span B to C we have 0 moments. So this is how we have to analyze shear forces acting in the beam and bending moment in the beam. So for any doubts you can contact me, you can comment and ask the questions what doubts you have. If not, repeat the video, solve slowly one by one, step by step, and clear your concepts. So thank you students. For further notifications and upcoming videos, subscribe the channel, like, share and comment.